Could Proxima B be another planet similar to Earth? These are theories that people continuously propose. The quest for an alternative habitable planet and extraterrestrial life elsewhere captivates human curiosity. Numerous hypotheses have emerged, and the occurrence of signals from Proxima B fuels speculation about deeper truths. Despite these indications, we have yet to ascertain whether these are messages from the planet or merely reflections of our own scientists' communications. Often, these signals turn out to be echoes. In the pursuit of determining whether these signals genuinely originate from Proxima B, researchers aim to discover if alien life exists. Recently, the James Webb Telescope detected artificial illumination on Proxima B. If you're keen on learning about other celestial bodies and our advancements in the search for alternate life, subscribe to our channel. We create content about outer space and discuss scientific innovations. If you enjoy this material, please comment below and share this video with your friends. Now, let's return to our presentation. Proxima Centauri, located approximately 4.2 light-years from our solar system, is a dim dwarf star classified as G-type. This star is known as Proxima Centauri. It was named Alpha Centauri in 1835 by Johann Bardeen, derived from the star's ascension at noon when several celestial objects, such as the Moon and the Sun, aligned. Proxima Centauri is also referred to as Alpha Centauri A or Alpha Centauri. It is a solitary star system featuring 4 main stars in alignment, with Proxima Centauri at the center of this configuration. In addition to the 4 stars, there are 2 faint dwarfs, Alpha Centauri B and Alpha Centauri C, which constitute the majority of the mass but are too dim to be visible to the naked eye. The system is positioned 23 light-years from the renowned Plough asterism in the constellation of Centaurus. Even though Proxima B is a terrestrial planet, there remains hope that it might harbor extraterrestrial life. The search for any form of life has drawn scientists to Proxima B. They speculate that its similarities to Earth's size and its distance from its dwarf star render it a plausible candidate for planets capable of supporting life. While all of this is conjecture, there is hope that some of it may hold truth. There is much to learn about Proxima B and its orbital patterns, so stay tuned for updates. You can also explore some of our other content related to extraterrestrials. Do you truly believe there is life beyond Earth? Leave a comment below. What intrigues many about Proxima B is its resemblance to Earth. Research indicates that Proxima B is an exoplanet that revolves around an M-type star. Its mass is estimated to be 1.27 times that of Earth. Additionally, Proxima B completes an orbit of its star in 11.5 days. Discovered in 2016, it has captured the attention of many scientists. Although Proxima B appears similar to Earth, certain characteristics render it uninhabitable. Primarily, the planet is situated too close to its star, which exposes it to extreme ultraviolet radiation. It is estimated that this radiation is hundreds of times more intense than that which we receive from the Sun. Such strong radiation strips away even the lightest hydrogen molecules and, over time, affects oxygen and nitrogen as well. While many might argue that Proxima B should be habitable due to its comparable distance from its star as Earth is from the Sun, there is much more to consider. Distance alone does not account for the presence of water on the planet. There is also a lack of evidence for an atmosphere that could support life. The atmosphere on Earth is what renders it livable, unlike Mars. A suitable atmosphere allows for climate regulation and a water-friendly surface. It also protects living organisms from harmful space weather. If you're with us thus far and haven't subscribed yet, please take a moment to hit the subscribe button. It helps us continue creating content like this that you'll enjoy. Now, let's examine why many believe the James Webb Telescope will aid us in discovering if life exists on Proxima B. Launched in 2018, after delays since 2011, the James Webb Telescope underwent numerous modifications to ensure it produced accurate images during development. Webb explained that if a planet like Proxima B could absorb light from its star, it could also emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can capture images of this light on a planet's surface and search for patterns that might confirm the presence of water or an atmosphere. One reason space telescopes are favored over ground-based ones is that being above the atmosphere allows them to see deeper into space without interference from shifting air. Thus, They provide a clearer view of what transpires outside our solar system than most ground telescopes can achieve. Another advantage is that weather changes on Earth do not impact them, ensuring astronomers obtain a clear reading. The only downside to having a space telescope is the high cost of repairs. If something malfunctions, there have been instances where a minor flaw in a space telescope necessitated a complete mission to fix it. Such expenses make the observation of planets like Proxima B challenging. With the James Webb Telescope, there are no options for rescue. It has been launched over 1.5 million kilometers away, further than any human has traveled, rendering rescue missions impractical. The James Webb Telescope features a larger mirror. As a result, we can observe the universe's beginnings, nearly 13.7 billion years ago. The further an object is, the further back in time we see it. This is because light takes time to travel from an object back to us. The James Webb Space Telescope's ability to perceive the universe in longer wavelengths of infrared light allows us to observe more distant galaxies with greater certainty than previously possible. Therefore, observing planets like Proxima B has become easier, pushing light beyond the visible spectrum and into infrared. Tabor and Loeb have developed a scale of artificial illumination as a fraction of how the sun illuminates and reflects on the planet's dayside. At 0% on the scale, one would assume that the planet's night side is entirely dark, with no illumination. At 100%, it means that the planet's night side is as bright as the day side. There has been a hypothetical civilization on Proxima B utilizing this type of light, and most scientists believe it resembles the early days on Earth. With the spectrum, studies indicate that if Proxima B's night side achieves an illumination level of 5% of the natural day side, the James Webb Telescope could detect the artificial light with an 85% likelihood. If illumination reached 9%, the telescope would detect it up to 95%. Although 5% illumination seems minimal, we are discussing light from a star as distant as Proxima Centauri, compared to our Sun. We have illumination that is 20,000 times dimmer, yet we still receive substantial light from our star. This essentially means that at 0.1% illumination, we still reflect the stellar illumination. In other terms, if Proxima B hosts any civilizations that illuminate like Earth, the James Webb Telescope would be unable to identify them. The stars would need to shine approximately 500 to 1,000 times brighter. This situation is unlikely, given Proxima B's close orbit around its parent star. It's possible that it could be tidally locked, meaning one hemisphere of the planet constantly faces the star, while the opposite remains in perpetual darkness. A civilization residing on a tidally locked world might need to prioritize light-producing infrastructure and utilize exceptionally bright orbital mirrors to redirect sunlight from the daylight side to the night side. All these are theories put forth by Tabor and Loeb, and no evidence yet exists to substantiate their assertions. Earth's luminosity can be observed from space and is termed airglow. Many wonder why the planet appears surrounded by vivid shades of red, yellow, green, and purple light when seen from 300 miles above its surface. Airglow happens when atoms and molecules in the upper atmosphere emit light to release excess energy. On Earth, this phenomenon can occur when atoms and molecules are ionized by sunlight and capture free electrons. The glow resembles an aurora, although auroras are caused by high-energy particles from solar wind. Airglow occurs daily due to solar radiation. Since the launch of the James Webb Telescope, scientists have been questioning its capability to observe distant planets in other galaxies. Despite being the furthest satellite telescope ever launched, it still provides very limited information needed to identify potentially habitable planets elsewhere. As a result, discussions have emerged about creating larger and more sophisticated telescopes. These endeavors are often costly and involve considerable trial and error. The launch of the James Webb Space Telescope was postponed by 5 years due to these challenges, hindering many scientists from developing better innovations that could be sent deeper into space. Nonetheless, the findings from the James Webb Space Telescope are encouraging. Soon, we might uncover whether life exists on Proxima B and other worlds. While further improvements in telescope technology are in progress, it is expected that the completion and launch of the Habitable Exoplanet Observatory, HABEX, will revolutionize space exploration. The anticipated completion date for HABEX is 2035, with a launch expected shortly thereafter. HabEx will be sensitive to all planets in the cosmos. Although its main objective is to search for Earth-like planets, its advanced technology will enable it to analyze the spectra of most planets and assess their habitability. HabEx is also expected to possess a diverse range of astrophysical capabilities. This feature will allow HabEx to study the earliest epochs in the universe's history, gather data, and comprehend the life cycles and end stages of massive stars, along with the elements that support life as we know it. Even though HabEx is still in the production phase, the technology utilized in its development will permit it to examine Earth-like planets at such remarkable resolution that the images captured will be exceptionally clear. HabEx will be sensitive to ultraviolet, near-infrared, and optical photons. The vision behind HabEx is quite compelling and will transform space exploration as we understand it. The concept of HabEx seems ambitious, and if successfully realized, space exploration will undeniably undergo significant transformation. People can look forward to more information regarding extraterrestrial life on other planets. It will also deepen our understanding of Earth, as it can delve back many more years into the planet's past, providing insights into the changes our climate has undergone. Lucy's concept is a more compact version of a telescope that still builds upon our experiences with the James Webb Space Telescope. It has ultraviolet capabilities and is expected to become the next primary observatory telescope for many astronomers. Plans are in place to launch Lucy simultaneously with HabEx. The large UV optical Earth surveyor will greatly enhance our comprehension of space. Preliminary studies conducted with Lucy indicate that it will clarify what differentiates Earth from other planets. Observations of 28 Earth-like planets have yielded promising outcomes. With such telescopes in development, details about planets like Proxima B may become clearer. Even though the James Webb Space Telescope has made significant strides in revealing new information about Proxima B, much remains to be explored. Enhanced visibility of other planets and the ability to analyze atmospheres differently are essential to address the question of extraterrestrial life. This will also offer profound insights into the planet's history and the changes it has undergone over time. Have you ever wondered what would happen if we found extraterrestrial life? Fear not. We have videos on our channel discussing this and much more. Subscribe to our channel and activate the notification button to be alerted whenever we upload new content. Is there life beyond our planet Earth? The conversation surrounding life on other planets has persisted for quite some time. Many individuals believe we are not alone in the galaxy. Numerous theories have emerged, and claims have been substantiated for years. Whether we ultimately determine if life exists on other planets depends solely on the type of research we conduct. For this reason, scientists are committed to ensuring we have more space telescopes orbiting Earth and other celestial bodies. However, these telescopes need to be more powerful and observe beyond infrared light to provide better answers regarding various forms of planetary life. For now, we watch with eager anticipation as we hope to discover if our neighboring planet, Proxima B, harbors any signs of life. If you enjoy content like this and want to learn more about the James Webb Space Telescope and Proxima B, please subscribe to our channel. We produce videos weekly, conduct telescope reviews, and explore the evidence of Earth-like features on other planets as we search for life beyond our world. Like this video and leave a comment below if you believe we are not alone in this galaxy. The quest for extraterrestrial life is progressing. One of the fascinating aspects is the potential discovery of biosignatures that could indicate the presence of life on exoplanets like Proxima B. Beyond detecting artificial illumination, scientists are exploring other possible signs of life, such as atmospheric compositions and chemical signatures. For instance, the detection of specific gases like methane or oxygen, alongside their balance with other atmospheric elements, might suggest biological activity. Another promising method involves analyzing the surface conditions of the planet using remote sensing techniques. Instruments designed to examine reflected light from a planet's surface can provide valuable insights about its geology and climate. By scrutinizing these details, researchers can infer whether the planet might have liquid water or other essential components for life. Moreover, there is growing interest in the notion of biosignature gases that could indicate life. For example, an imbalance between gases such as carbon dioxide and oxygen could imply biological processes. Research into these indicators is ongoing, with hopes that future telescopes will be capable of detecting these subtle yet critical signs from distant worlds. Additionally, upcoming space missions and technological advancements are expected to enhance our ability to identify and study exoplanets. For instance, the development of next-generation spectrographs and more sophisticated observational techniques will improve our capacity to analyze the atmospheres and surfaces of these far-off worlds.